we're going to apply our understanding of our trigonometric functions within the coordinate grid to our trigonometric functions with triangles that are outside the coordinate grid. If we consider an angle in standard position, like this diagram we have here, we can see that when we have the y value over the r value for our sine, y represents our side opposite, while r represents our hypotenuse. This may be familiar to the mnemonic that we've seen before of SOHCAHTOA. Opposite over hypotenuse. Tangent or cosine is our adjacent over hypotenuse, and tangent is our opposite over our adjacent. So if we take our triangle and we remove it from the coordinate grid, where we don't have x and y's, we still end up with the same ratios. Now, as we move to triangles not in the coordinate grid, we have to consider the relative position of the angles and the sides. So considering that when I want to find sine of an angle, if I find the sine of angle A, for angle A, the side that is opposite of angle A is 7. But if I consider angle B, the side that is opposite for angle B is not 7, now it's 24. So the angle that we're considering is very important when we're looking at finding our trig functions for those given angles. So for angle A, our opposite side is 7, while our adjacent side is 24. Our hypotenuse is 25. We know that's our hypotenuse because it's opposite the right angle. And then for angle B, our opposite and adjacent sides switch. Hypotenuse will always be hypotenuse. So we can find sine of A. Sine of A is our opposite side over our hypotenuse, 7 over 25. Cosine is our adjacent over hypotenuse, 24 over 25. And tangent is the opposite over the adjacent, giving us 7 over 24. While sine of B, since opposite and adjacent are switched, that means sine is now going to be 24 over 25. Cosine will be 7 over 25. And tangent will actually be 24 over 7. So every place where we used opposite and adjacent switched when we changed our angle. If we don't know our side lengths, we can use Pythagorean theorem. We have side A, we have side B, and we have side C. Opposite angle A was side A, opposite angle B is side B, and C is C. So with our theorem, we have side A, we can square it. We're solving for side B, and we have side C that we can square. 9 times 5, 45 plus B squared equals 81. B squared is 36. That means side B is 6. So we're going to start with referencing angle A. Opposite is 3 root 5, and hypotenuse is 9. And then we want to simplify the fraction root 5 over 3. Cosine, adjacent to angle A, is side B, and our hypotenuse, which reduces to 2 over 3. And then tangent will be the opposite side of A divided by the adjacent side, and again simplifying our fraction. Angle B's opposite side is 6. Angle B's adjacent side is 3 root 5. And then our tangent is going to be 6 over 3 root 5, which gives us 2 over root 5, and then we rationalize to 2 root 5 over 5.